mag-aral na tayo. Halina, 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 mag-aral na tayo.
Thank you very much, Ma'am Marisa Pasion, for that very comprehensive review lesson for Grade 7, Quarter 3, Lesson 1, Mathematics. This time, allow me to introduce to you our review teacher for Learning CLAID Module, Mathematics Grade 8, Third Quarter, Lesson 1. She is a teacher from Mataas sa Paaralang Natalie Gonzalez, a very beautiful teacher, a dynamic teacher, and of course, a very intelligent teacher. Let us all welcome mga Batang MANDunong, ang ating review lesson teacher para sa third quarter lesson 1, week 1. Walang iba kundi si Mrs. Marisa Banyares o Tito. Ma'am, it's your turn na po. Good luck po.
Hi there, Batang MANDunong. I am Teacher MARIPAZ, and I will be your teacher for this Advanced Mathematics Grade 8 lesson for Quarter 3, Week 1. So let's get started, Batang MANDunong. For our objectives, describe a mathematical system, illustrate the need for an axiomatic structure of a mathematical system in general, and in geometry in particular, define terms and undefined terms. What is geometry? Let us define with the help or using the following pictures. Name the given pictures. A book, a globe, and the measuring tool. That's great. Therefore, geometry is the study of Earth's measurement. In your grade 7 lesson, you were already introduced to the world of geometry and its mathematical system, including the undefined terms, defined terms, axioms or postulates, and the theorems. Undefined terms. Terms that cannot be defined but can be described or represented. Defined terms. Terms that have a formal definition and can be defined. Axioms or postulates are statements accepted to be true without proof. Theorems, statements that are proven to be true using definitions, axioms or postulates, and derived using reasoning. Now let us study the undefined terms. We have three undefined terms. We have point, line, and plane. These undefined terms are said to be the building blocks of defined terms and axioms or postulates. From this, undefined terms were all started. And it all started from a point. You can Google it and find it in your dictionaries. There is no definition, just a representation. It has no length or width, but it indicates a position or location. It is represented by a dot. It is named using a capital letter. Let us name a point. Let's say we have here a point. So we can read and write that as point A, or let's have another one. And or get that? Now let's have an examples or representations of a point. The tip of a pen. And of course, your eyeball. So these are some of the representations of a point. The next undefined term is a line. It has infinite length but has no width and thickness. It extends infinitely in two opposite directions. It is represented by a straight line with two arrowheads. A line is named by two of its points with a symbol written on top of two letters. That is named a line. Adding another point, we can create a line by connecting the 2 points, because 2 points determine the line. To name a line, we use the points such as points A and B. So in line, it is named like this: line AB, and to write it in symbol, we usually draw a line bar above the 2 points. So it could also be line BA, and write this as a symbol. Sometimes, we use a lowercase letter in naming a line. So we could name this line as line M. Let's have now examples and representations of a line. Edges of the table and the hair strands. So these are the representations of a line.
There are two subsets of a line. When we say subset, it is just part of a line. The first one is a line segment. When we say line segment, it has two endpoints. Endpoints cannot extend the line in both directions. Let's have an example. We have here line segment FI or IF. So the line segment is from point F to point I only. It has endpoints. Or we could just write end symbol using the bar on top of the two capital letters. Next example is the line segment IT or TI. So from point I up to point T only. So here is the symbol. And the last one is the line segment FT or TF. So from point F to point T. Here's the symbol. So this is line segment FT or TF. The other subset of a line is the ray. It has one endpoint and the other extends infinitely in a set direction or in one direction. For example, we have ray Fi. To name a ray, always start from the endpoint to another point that lies on a ray. So from point F, the first letter is the endpoint. So from point F to point I and extends infinitely to the right. And that is the symbol for ray. It has one arrow. For the ray TF, so the endpoint is point T. To the left, and it extends infinitely from point F. And the last one, we have the ray IF. The endpoint is point I. From point I to point F, and it extends infinitely to the left. Now let's proceed to the last undefined term, which is the plane. It is a flat surface extending infinitely in all directions. A plane has infinite length, infinite width, but has no thickness. It is usually represented in drawings by a four-sided figure. Let's name a plane. In naming a plane, we use three or more capital letters. For example, in this figure, the name of a plane is plane HOME, or in symbol, we use the quadrilateral symbol here, HOME. Take note that we use a four-sided figure as we name the given plane using a symbol. We could also use the points inside the plane to name the plane. So we could also name this as plane TAC. Let's have examples or representations of a plane. The walls, floor, and ceilings are examples or representations of a plane. Now let us answer more examples. Using figure 8, name the given line in different ways.
Very good. We have line AB, line AC, line AD, line BC, line BD, line CD, line BA, line CA, line CD, line DB, and line DC. Let's have another one. Using figure B, name the given plane in different ways. That's great. Plane M, plane XYZ, plane XJY, plane YZX, plane YXZ, plane ZYX, and plane ZXY. Good job. Now let's proceed to the defined terms. Since the undefined terms are the building blocks of defined terms and axioms and postulates, therefore, defined terms have formal definition and can be defined using other geometrical terms. Through axioms or postulates, no need to prove if the definition is accepted or not because, according to theorems, all statements are proven to be true using definitions and axioms or postulates. Under defined terms, collinear points, coplanar points. Collinear points are points that lie on the same line, while coplanar points are points that lie on the same plane. Given the figure, point X, point Y, and point Z are collinear points, while point A, point X, point Y, and point Z are coplanar points. Parallel lines are lines in a plane that do not intersect or meet. The symbol for parallel to is line M and line N are parallel to each other. Perpendicular lines. Two lines are said to be perpendicular lines if they intersect or meet and form right angles. The symbol for perpendicular to is, for example, we have line WY intersect with line XZ and form a right angle. Therefore, line WY is perpendicular to line XZ. Midpoint of a line segment. A point on a line segment that divides it into two equal parts, or the halfway point of a line segment. For example, if B is the midpoint of segment AC, then BA is equal to BC, or segment BA is congruent with line segment BC. For example, segment AC is equal to 10 centimeters, and B is the midpoint of segment AC. Then, segment BA is equal to 5 centimeters, same with segment BC is also 5 centimeters. angle. It is the figure formed by two rays called the sides of the angle, sharing a common endpoint called the vertex of the angle. Ray BA and ray BC are the sides of the angle, or this angle, and the vertex is point B, or their common endpoint. That is the vertex, point B. So angle, represented by the symbol, and also measured in degrees using a protractor. So there are three ways in naming an angle. We can name angles by using three capital letters. Given this figure, we have point A, point B, and point C. So we could name this angle as angle ABC, or in symbol, so angle ABC or angle CA. We can name angles by using the vertex. So what is the vertex here? We have point B, so we could name this angle as angle B. And symbol, we can also name an angle by placing any number or symbol at the vertex. So we have here 2 is in the vertex, so we have angle 2, or in symbol, right angle. It is one of the classification of angles according to the measure of an angle. A right angle is an angle whose measure is 90 degrees. The square corner is used to mark a right angle. Angle KAP is a right angle, or angle PAK. The middle is the vertex. It is always the vertex is in the middle. Angle pairs, or pair of angles. We have supplementary angles, complementary angles, vertical angles, adjacent angles, linear pair. So first we have supplementary angles. The sum of the measure of two angles is 180 degrees. Again, the sum of the measure of two angles is equal to 180 degrees. So angle LAB is 110 degrees. So what will be the measure for angle SIP? So that is 70 degrees to make it supplementary angles, or the supplement is 70 degrees. So measure of angle LAD is equal to 110 degrees, while measure of angle SIT is equal to 70 degrees. That makes it 180 degrees. Complementary angles. While supplementary is equal to 180 degrees, the sum of the measure of two angles here in complementary angles is 90 degrees. Given angle B and angle A, which is complementary angle, if angle A is equal to 20 degrees, therefore, angle B is equal to 70 degrees. To make it 90 degrees. Note, supplementary and complementary angles may not be adjacent. So what is an adjacent? adjacent angles if two angles, like angle A and B, have a common vertex and a common side, then they are called adjacent angles. Angle A and angle B has this common side. Therefore, angle A and angle B are adjacent angles, two angles that are next to each other, with common vertex and common side. Vertical angles. Vertical angles are two angles in which the sides of one angle are opposite ways to the other sides of the other angles. Okay. Given line HF intersects line ED, we form all vertical angles. Again, angle HGE and angle FGD are vertical angles. These two opposite angles are also congruent or equal in measure. Same with angle HGD and angle FGE are also vertical angles. These opposite angles are also congruent. So let's say angle HGE is 60 degrees. Therefore, the opposite angle FGD is also 60 degrees. If these two angles are congruent, same with angle HGD and angle FGE. So if this is 60 degrees, this is 120 degrees. And if this is 120 degrees, the opposite angles, our angle is also 120 degrees. Linear pair. If two adjacent angles, again, if two adjacent angles, like angle A and B, have their non-common sides forming a straight angle or opposite ways, then they are called linear pair. If angle A and B have their non-common sides forming a straight angle also equals to 180 degrees. So this is a straight line. So straight angle or opposite ways, then they are called linear pair. Adjacent angles, they are next to each other. They have common sides and vertex. So this is angle B and angle A with their opposite rays. So angle A and angle B are a linear pair. Linear pair, again, is also equal to 180 degrees.
Segment bisector is a point, a line, or a segment that divides the segment into two congruent parts. Segment MK is a segment bisector that divides segment LN into two congruent parts. angle bisector. It is an angle bisector, or it is a ray that divides an angle into two congruent angles. If the segment bisector divides the segment into two congruent parts, the angle bisector, it is a ray that divides an angle into two congruent angles. So ray OB is an angle bisector that divides angle AOB and angle COB. So if ray OB is an angle bisector, then measure of angle AOB is equal or congruent to measure of angle COB. We are done with our lesson. So let us answer more of the examples. Complete the if-then statement. Justify your answer by using the definitions. Given the figure, if A is the midpoint of JM or segment JM, then you are right. Segment JA is equal to segment MA. Solution: since A is the midpoint of segment JM, then JA is equal to segment MA by definition of midpoint. Next, given the figure, if ray OM is perpendicular to line LN, then you are correct. Angle MON is a right angle. The solution: since ray OM is perpendicular to line LN, then angle MON is a right angle by definition of perpendicular lines. For the last example, given angle C and angle B are complementary angles, and measure of angle C is 53 degrees, then the measure of angle D is very good, 37 degrees. Since measure of angle C plus measure of angle D is equal to 90 degrees, and measure of angle C is 53, then measure of angle D is equal to 37 degrees by definition of complementary angles. We just have to subtract 90 degrees to 53 degrees to get 37 degrees. To wrap it up, we have geometry, mathematical system, undefined terms, point, line, plane, defined terms, collinear points, coplanar points, parallel lines, perpendicular lines, angle, right angle, segment bisector, angle bisector, angle pairs, supplementary angles, complementary angles, adjacent angles, vertical angle, and linear pair, axioms or postulates, theorems. Don't forget, stay healthy, helpful, and calm. Stay home, stay safe. You matter. At Batang MANDunong, walang maiiwan kabahagi ng bilang. With that, again, I am Teacher MARIPAZ from Mataas na Paaralang Neptali A. Gonzales, saying thank you everyone.